In this video, I'm going to focus on showing you how to take an arithmetic sequence and write a recursive function for it and an explicit rule function for it. So let's look at the sequence 6, 9, 12, 15, and 18. Looking at it, you can probably determine what we jump by each time, and that's called the common difference. So when we write a recursive or an explicit rule, both times we first find the common difference, and in this case it's 3. So each term in the sequence, okay, we can write as f of whatever position number it has. So f of 4 is the 4th term in the sequence. And again, the common difference is 3. So when I write the recursive rule, you first tell what the first term is. So if you look over here at the right, the algebra says given f of 1. Given f of 1, then f of n equals f of n minus 1 plus d. d is the common difference. So in this case, f of 1 is 6, because that's the first term in the sequence. So then the recursive rule for it will be f of n minus 1 plus 3, since 3 is that common difference. What this means is that if I want to find a term in the sequence, say I want to find f of 5, that means that I would find f of 4 and then add 3 to it. I would find the term in the 4th position, then add 3 to it. So if I was continuing here, the 4th term in the sequence is 15, so this would be 15 plus 18. So when they ask you to write a recursive rule for a sequence, this is your answer. Now there is a reason why it says for n greater than or equal to 2. Because if n is less than 2, let's say it's 1, if I put 1 in for n, this would be f of 1 minus 1 plus 3. That's f of 0. Well, we didn't have a term that was in the 0 position, so it doesn't exist. So this function rule only works if I start with an n greater than or equal to 2. Now, when I write my explicit rule, what we need to know is still the common difference and the first term. The first term will go here, okay, which I'll write in algebra, that's f of 1. And then the common difference is d. And then I'll put that common difference here. In the example that we had in the notes, up here, we talked about how the common difference is the slope. And the first term is like the y-intercept. But the problem is that if I don't write this piece here the way it is, I'll be one term off. So since my position number starts at 1, in order to get my first term, this piece has to be 0. In order to make that happen, I have to do 1 minus 1, which is 0, then multiply that by the common difference. That's still 0. Add it to my first term, so I get my first term. So looking at this sequence here, let's see if we can get the first term the way we need to. The first term would be position 1. Now then, if we do order of operations, 1 minus 1 is 0. 3 times 0 is 0. F of 1 is 6. That's my first term in the sequence. That's how you can check your answer. Okay? So there's very similar things between a recursive rule and an explicit rule. The difference is that in explicit rule, I do not have to know the term before it in order to find the term in that position of the sequence. So if I wanted to find the number in the 10th position, I would do 6 plus 3 times 10 minus 1. 10 minus 1 is 9. 3 times 9 is 27. 6 plus 27 is 33. So f of 10 is 33. Okay, this way you can just find whatever term you want. But recursive, you have to know the one before it in order to get the next. Okay? So, let's see. Okay, let's talk about this a little bit. So it says represent the sequence in the table. Here's our inputs, 1, 2, 3, 4. Okay, my outputs are the 75, 100, 125, 150. Is the sequence arithmetic? Explain how you know. If it's arithmetic, we'll have a common difference. That common difference in this case is 25. Okay, and we use D as our variable for that common difference. Oop, so then there we go. I tend to get a little ahead of myself when I answer questions. So if I want to write an explicit rule for this sequence, it would be f of 1, my first term, plus my common difference, D, times n minus 1. Okay? So f of 1, my first term in this case is 75. My common difference is 25. So 75 goes in for f of 1 and 25 for D. So this sequence has the rule 75 plus 25 times n minus 1, where n is the number of passengers and f of n is, I believe, the cost, if I remember correctly. Yep, cost. So this would be cost. Okay. An arithmetic sequence is equivalent to a function with a restricted domain, meaning we don't just have all real numbers. In this case, we only have positive whole numbers, 1, 2, 3, 4. So we've talked about how an arithmetic sequence is like y equals mx plus b, but instead of x, we're using n, and instead of y, we're using function notation. So we're going to draw the line passing through the points up here. And we're going to try and write an equation using slope and y-intercept, m and b. B is my y-intercept, or my initial term, which would be 50. And then my slope looks like I go up 25 over 1. Because each box vertically is worth 25 and horizontally is worth 1. So this would be f of n equals 25n plus 50. Now we're going to see something very interesting. We're going to show that the explicit rule, what we got here, well, no, that's the explicit rule. I was thinking that we were going to do something else that I think we're going to do on the next page. What I was wanting to say is that if we compare this rule here to the rule that we came up here, came up with here. This is the explicit rule. And this is the recursive. We'll actually find that they end up being the same thing if I do some simplification. But I think we're going to do that in the next page. Oh. Nope, I guess not. So let's do it. If I have 75 plus 25 times n minus 1, what I'm going to do is simplify first by distributing. And then combine like terms. Well, what's 75 minus 25? It's 50. So if I simplify this function rule that we came up with here, then I get this answer right there. Okay? All right. Let's do a couple of practice problems. Say we have this sequence. And I want us to create a recursive rule and an explicit rule. A recursive rule, what we need to know is we need to know the first term, and we need to know the common difference. The common difference here is what I change by each time, which this here we're adding 4. So the common difference is 4. So then I would write f of n equals my first term plus my common difference, which happens to be the same, times n minus 1. Nope, that's not the recursive rule. Gosh darn it. Hold on. F of 1 is 4. Nope, this is the explicit rule. Oh, yeah. Okay. I remember now. Okay. So if f of 1 is 4, then this, here we go. Okay. What this means, and again, I got confused between the recursive and the explicit rule, which this is why I was doing it, because it can get confusing. So I'll be sure and keep doing more examples until we get it down. But all right. So f of n minus 1 means I take the number in the position before the one I'm looking at, then I add 4. So if I want to find, for example, f of 3, we know f of 3 is 12. Okay, so we know that. But I'm going to continue with the function notation. So I put 3 in for n. 3 minus 1 is 2. F of 2 is 8. 8 plus 4 is 12. Okay. So this is the way to check your answer. If you plug in a value, you get the same, you get what you should, then you're good. But there's one thing that I should add. For a recursive rule, this only works when n is greater than or equal to 2. Because if n is less than 2, say it's 1 or 0, then 1 minus 1, if I were to put that here, that's f of 0. There is no term in the 0 position. So it doesn't make sense. Now the explicit rule was what I was writing, because my habit is to go for the explicit rule because that's the one that's the most helpful. The explicit rule, all you do is you take your common difference times, okay, the position number minus 1 plus your first term. Okay, so again, if I wanted to check this here, let's do f of 4. So 4 minus 1 is 3. oops, forgot the plus 4. 4 times 3 is 12. 12 plus 4 is 16. Okay, drum roll. Let's see if the number in the fourth position is 16. Yep, sure is. So then that's right. So this is my explicit rule, meaning I can just plug a number in, get my answer. This is my recursive rule, and it's all of those three pieces. Okay, that is my recursive rule because I look at the term right before it to know the next one. Okay, so let's do another one. This time I'm going to do a sequence that decreases because we've so far been doing ones that increase. Okay, so let's start with the recursive. And this time try and make sure that I explain this correctly. Okay, recursive rule. First we find the common difference. The common difference is subtracting 10. So when I write D, since I'm subtracting 10, D is actually negative 10. And the first term of the sequence is 50. So to get my nth term, I would find the term right before it and then subtract 10. Again, when n is greater than or equal to 2. So let's double check. So if I want to find f of 4, f of 4 we know is 20. So when we check this, we should see if we've got it right. 4 minus 1 is 3. The third term in the sequence is 30. 30 minus 10 is 20. Good. So we got that right. So that's my recursive rule. For my explicit rule, I need my common difference and I need my initial term. My initial term is 50. My common difference is negative 10. And I multiply that by my position number minus 1. Now, I could have written 50 plus negative 10, or I could have also written it this way. Either way is fine. Okay? So then if I want to check, let's find f of 2. So the number in the second position. I would do 50 minus 10 times 2 minus 1. 2 minus 1 is 1. Negative 10 times 1 is negative 10. So 50 minus 10 is 40. So let's see, is the number in the second position 40? Sure is. So then that's right. Okay, I'm going to do one more example. Let's see, I'm going to try and make one that's a bit more challenging. Okay. So let's do the recursive. To do the recursive sequence, I first find my common difference. My common difference in this case is I'm adding 1/4. The reason why it goes from 1/4 to 1/2 is because 1/4 plus 1/4 is 2/4. 2/4 is equal to 1/2. So my difference, common difference is 1/4. My first term is 1/4. So my function for a certain term value, I have to take the term right before it and then add my common difference when n is greater than or equal to 2. So you see the recursive rule basically follows the same pattern each time. The only thing that will change are these two numbers right here, the first term and the common difference. Now the first term and the common difference may not always be the same. Just with the ones that I was coming up with, that's just what my brain came up with. So that's the recursive. Let's do the explicit. The explicit rule, what I need is I need the first term and the common difference. Except I put the common difference here, and then I add the first term. Now again, it so happens here that they end up being the same thing, the first term and common difference. So let's double check and make sure our answers are correct. Let's check the recursive rule for f of 4. That would require that I look at f of 3 and then add 1/4 to it. So f of 3 is 3/4, right here. If I add 1/4 to 3/4, will I get 1? I sure do. So that's good. So my recursive rule is good. Now let's check the explicit rule. Let's check it for 6. Let's find f of 6. It's 1/4 times 6 minus 1 plus 1/4. 6 minus 1 is 5. 5 times 1/4 is 5/4. 5/4 plus 1/4 is 6/4. That reduces to 3/2, which is equal to 1.5. Is that the sixth term in the sequence? Let's see. 1, 2, 3, 4, 5, 6. Sure is. 1.5. So that works. So here is my explicit rule. Okay? So in your assignment, okay, which is the practice here, you're only doing evens. So remember that. You're only doing evens. For these problems here, you're just plugging in values. So for number 2, for example, to find the first term in the sequence, I would put in 1 for n. That's going to be 2/4, which is 1/2. So 1/2 is the first term in the sequence. Then I would go on from there. Okay? You would do the same thing here in this problem, except this is a recursive sequence. So if f of 1 is 16, that means if I wanted to find f of 2, I would take half of f of 1. Well, if f of 1 is 16, half of 16 is 8. So 8 would be my next term. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. So on and so forth. But we're only finding the first 4 terms. Okay. Now 8's going to be a bit of a challenge. I want you to try and think about that one yourself, though. Okay. Now number 10, that is an explicit rule. So this is one where I can just plug in a value for n and then simplify. Okay. Here you're writing the rule. So look at your value, your numbers, and here you only have to do number 12. Look at your common difference. So you're writing an explicit rule. You need your common difference and your first term, and then it will be just like what we did when I was giving examples. Okay? All right. Hopefully that should help you with completing your homework here. If not, of course, come into Encore tomorrow. Come see me in the morning. Or you could also text me this evening. So either way.